Welcome to Properties of Trapezoids and Kites. Today's objectives are to use properties of kites and trapezoids to solve problems. Let's first discuss what a kite is. A kite's a quadrilateral with exactly two pairs of congruent consecutive sides. So a kite is a quadrilateral with exactly two pairs of congruent consecutive sides. And we have two properties of kites that we want to discuss. Okay, for our first image here, we're going to discuss the diagonals of a kite. So, if a quadrilateral is a kite, then we know that the diagonals are perpendicular. So if a quadrilateral is a kite, then we know the diagonals are perpendicular. The second property of kites. If we have a quadrilateral that's a kite, then exactly one pair of opposite angles are congruent. So if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So for our first property, this one here says that segment BD is perpendicular to segment AC. And for our second property down here, we know angle B is congruent to angle D. And just as importantly, we know that angle A is not congruent to angle C. And those are our two properties for kites. Let's use the properties of kites to determine the measures of these angles. In kite EFGJ, the measure of angle FEJ is 25 degrees, and the measure of FGJ is 57 degrees. Let's find each measure. So the first thing I'm going to do is mark up this information. So I know that angle FEJ, which is this angle right here, is 25 degrees. I know angle FGJ, which is this angle right here, is 57 degrees. So the first thing we want to find is the measure of GFJ, which is this angle right here. Now, what I would do is draw this triangle FJG. Now, the reason I'm going to do this is because I know the diagonals of a kite are perpendicular. So I know that angle there has to be a 90-degree angle. So if this is 90, I know this angle is 57. That makes it much easier to figure out what this angle is right here. Therefore, I know the measure of GFJ equals 33 degrees, because the sum of an interior angle of a triangle has to be 180. Okay, next one. We are looking for the measure of angle JFE. Angle JFE is right up here. Similar setup to the previous problem. I have my triangle. This has to be a 90-degree angle. This one has to be 25. So I know that this last angle here has to be 180 minus 90 minus 25, which equals 65 degrees. Alright, our last one is asking us for the measure of angle GHE, which is this whole angle right here. Now, I know that the opposite angles of a kite are congruent, but only this pair right here. So, I know that the measure of GHE is congruent to the measure of GFE. So, what that means, if I know these two angles right here, I know the measure of angle GHE. And I do know that, because we found the measure of GFJ, which is 33 degrees, and we found the measure of GFE, which is 65. So I'll add those two together, and I get 98 degrees. The next quadrilateral that we're going to be studying is called the trapezoid. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. We know each one of these parallel sides is called a base. And the non-parallel sides are called legs. And lastly, we have what we call base angles. Now, base angles of a trapezoid are two consecutive angles whose common side is a base. So, for example, angle A and angle D are base angles. But angle A and angle B are not base angles. And the reason for that is because it has to be two consecutive angles whose common side is a base. For A and D, their common side is this base right here. So it works. But for A and B, this is not a base, it's a leg. So those are not base angles. So we have a special type of trapezoid called an isosceles trapezoid. Now you have an isosceles trapezoid if the legs of a trapezoid are congruent. And isosceles trapezoids have certain properties that we're going to be discussing. Alright, let's talk about the base angles theorem. So, if we have a quadrilateral that is an isosceles trapezoid, then we know that each pair of base angles are congruent. So then the base angles are congruent. So in this image here, angle A is congruent to angle D, and angle B is congruent to angle C. Okay, the next theorem says if we have a trapezoid and it has one pair of congruent base angles, then the trapezoid is isosceles. So if we have a trapezoid and it has base angles that are congruent, then we can make the conclusion that we have an isosceles trapezoid. So in this example, we don't know it's an isosceles trapezoid to begin with. All we know is that the base angles are congruent. And for our last one, if we're given a trapezoid, we know it's an isosceles trapezoid if and only if the diagonals are congruent. So we'll say a trapezoid is an isosceles trapezoid if and only if the diagonals are congruent. And these are our theorems for an isosceles trapezoid. Let's use the properties of isosceles trapezoids to help us find measurements. So for example A, we're trying to find the measurement of angle Y. So what we're given is the measure of angle W is 117. Now, since I know that this line is parallel to XY, I know that angle W and angle X are same side interior angles. And I remember that WX being same side interior angles means that they are supplementary. So that means they add up to 180. So I'll do 117 plus the measure of angle X equals 180. And that means the measure of angle X has to equal 63 degrees. Now, am I trying to find X or am I trying to find Y? Well, since this is an isosceles trapezoid, I know the base angles have to be congruent. So since the base angles are congruent, I know that the measure of angle X is congruent to the measure of angle Y. So if I know X, I know Y. So the measure of angle Y is 63 degrees as well. Alright, for example B, we know that RT is 24.1 and the measure of QP is 9.6. let's find the measure of PS. So I'll mark up my diagram. I know that QP is 9.6, and I know that the measure of RT in its entirety, that's 24.1. Now I know that this is an isosceles trapezoid, so therefore I know that the diagonals are congruent. Since the diagonals are congruent, I can say that RT is congruent to QS. Now QS is made up of two segments. It's made up of QP and PS. Now what I'm trying to solve for is PS. I know RT and QP, so I just plug in and solve for PS. So I know that RT is 24.1, and I know that QP is 9.6. What I'm trying to solve is for PS. So I just subtract 9.6 from both sides and solve for PS. Which equals 14.5. In this example, we're going to find the value of y that would make this trapezoid an isosceles trapezoid. Well, we know that an isosceles trapezoid has to have legs that are congruent. Now, if the legs are going to be congruent, that means the base angles have to be congruent as well. So that means that angle E has to be congruent to angle H. So we're given measures for E and for H. You know that E is 2y squared minus 25. And we know that H is y squared plus 24. So here we just solve for y. So we subtract y squared from both sides, we're left with y squared. And we add 25 to both sides, and we're left with 49. Now, to figure out what y is, we have to take the square root of both sides, and we're left with y equals plus or minus 7. Now, if you remember from algebra, when you take the square root of both sides, the number can be positive or negative. The reason for that is plus 7 times plus 7 equals 49. But minus 7 times minus 7 also equals 49. So you can either plus or minus. If you've studied midsegments of triangles, this idea is very similar. So a midsegment of a trapezoid is a segment whose endpoints are the midpoints of the leg. So the midsegment is the segment whose endpoints are the midpoints of the legs. Now, the midsegment theorem is very similar to the midsegment theorem of a triangle. So the trapezoid midsegment theorem states the following. The midsegment is parallel to each base. So that says that xy is parallel to BC and xy is parallel to AD. And the second part of the midsegment theorem is that the length of the midsegment is half the sum of the bases. So in this diagram here, the length of xy equals 1/2 the length of BC plus AD. And that is the trapezoid midsegment theorem. So let's find the length of ST. So ST is one of the bases. We know the midsegment and we know the other base. So we know the length of the midsegment is equal to half the sum of the bases. So the midsegment is 31. We don't know one of the bases, let's call it x. So we do 38 plus x times 1/2 will equal 31. So what I'll do here is I'm going to multiply both sides by 2. And I do that to get rid of this 1/2. So I multiply both sides by 2. I get rid of these. I'm left with 38 plus x on the right side, and then with 62 on the left. I subtract 38 from both sides, and I'm left with x equals 24. And that's how you find the length of ST. That's the end of our video for today. Thank you and take care.